It says here, first activity, identifying qualitative graphs. That was the voting thing that we did last class. I fit it in then. Yay! Here's some data. Person is walking along a straight line, and they're being timed while their position from the starting point is recorded. The data is recorded below in the following table. So we have time and we have distance, and it says graph the data below. So here's a graph. You know what? First thing I'm going to do is a title. How about distance versus time? Let me just pause the video for a second here. Click. Time goes on the x-axis, so I'm going to label my graph time, comma, t, comma, in seconds. And then distance goes on the y-axis. Distance or position, but I'll just call it distance. I think this is going to be a scalar, comma, d in meters. Then we need to pick a scale. In the time column, what's the biggest value that shows up? Can you look? What? 9? Or is that a German student saying no? 9? No, sorry. Do you actually put that number in there for the joke? No, I would never do something. Anyways, 9? Okay, how many squares along the bottom do we have? 22 small squares, 11 big squares. You know what? Let's go, every thick hash mark can be 1. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That works. What's the biggest distance value that appears? 20? Oh, nice round number. How many vertical squares do I have? 2, 4, 6, 8, 10, 12, 14. I got to fit 20 in. I guess each small square is going to be worth 2. Like, I think it's going to go like this. 4 times 2, 8 times 2, 12. Times 2, or it's not times 2, plus 4, plus 4, plus 4, 16, 20, 24. Is that okay? Or Sheldon, I don't need to label the ones in between. Is that all right? We know the ones in between are going to be the other even numbers? Okay. Let's graph it. I'll go with red. Oh, heck no, I'll go with green for go, for moving. 1 second in, we're at 4 meters. Yay! 2 seconds in, we're at 6 meters, which I guess would be 1 square higher and 2 squares over, based on this scale. 3 seconds in, we're 8 meters. Oh, I'm spotting a pattern. Looks like on my graph, I'm going to go up 1 over 2, up 1 over 2. By the way, the fact that this works out so nice, Connor, tells you this is fake data, that I made it up. Real data, there's always noise. The person didn't quite go at an exact speed. I was a little sloppy on my stopwatch. So this is cooked data. You don't need to know that, but you know, hashtag nerd trivia. 410, 512, 614, 716, 818, 920. Hey, by the way, can you see if I continue to the y-axis where I'm going to put a dot? Can we agree right there? Yeah? Dot would go right there. Use a straight edge, use a ruler if you can. I didn't tell you to get the rulers out, so you can freehand if you really want to. I'm just going to draw here. Connect the dots. You know what? Let's even go really high tech, Mr. Dueck. Let's go draw line. Ooh. Ooh. So let's go right to there. It moved, darn you. Come on. And then this one's a bit off as well. Look at that. Hey, ha. There's my line of best fit. This one, Haley, unlike the data that we collected, there was no some too high and some too low and noise to split. It's fake data. All right, let's answer some questions. What's the y-intercept of this graph? Now we're going to answer this both as a number and in English what it means, because one of the things, Ryan, that I've been trying to tell you is in physics, y-intercepts and slopes actually mean something in the real world as opposed to just a number. So as a number, what's the y-intercept? I'll give you a hint. 0, comma, because the y-intercept is always 0, comma, 0, comma 2. What does that mean? Yeah. The distance, the starting point. This person, I did not start timing when this person was at 0, 0. This person must have walked for a little while before I started timing. Or they started away from me. That could be the other possibility. I usually just like to think that it means I said go. They started walking away from me, and then I hit my stopwatch, but they'd already gotten, okay? So this is the initial position of the person. Oh, Matt, that's way too much writing. Are we on a graph? Did I say that there was a good letter to use for position as an, for initial as an abbreviation? What did we say a few days ago that I was going to use for the rest of the year as my abbreviation for initial? Really? What letter? I. So you know what? Let's put a comma. I'm going to call it xi. X because we're on a graph. I for initial. You could, from now on, if I say that, Cohen, you'll know I'm talking about the initial position. I don't want to have to write out the phrase anymore. Okay? You could have said, by the way, di as well, because I did put distance, comma, d, whatever. What's the slope of this graph? Now, a lot of people, and this happened on the test that we just wrote, a lot of people would go, oh, the slope is 1/2. Now, that would be if you're counting squares, but that also means each square is worth 1. I don't think that's the case. So what's the, now, because this is a nice exact line, I could pick stuff really far apart, or I could just pick 2 points close together. You know what? I'm going to pick this point and this point. How high am I right here? 2. How high am I right here? What's the rise? Okay, now in our notes, because I think I lost some of you, if you want to, you can write 4 take away 2. That's how I found the rise. What's my x-coordinate right here? 1. What's my x-coordinate in line with this point? 0. 1 take away 0. Oh, this slope is not 1/2. It turns out this slope is 2. 4 minus 2 is 2, 1 minus 0 is 1. Can I trust that you can handle the math in your head? And then 2 divided by 1 is 2. Okay. Otherwise, you'd use your calculator and get a decimal. 2 what? Now, remember, this is the y-axis. What are the units on the y-axis? Meters. Rise over per. Oh, you mean the actual units tell me that the slope of this graph is also the what? I'm going to say speed just to be technical because I don't think I actually have directions here. But if you said velocity, I probably wouldn't freak out. But I'm going to say speed, comma. What letter did we use for speed? V, without the vector sign. Okay. What I'm saying, Alex, is if you said V, I'd take that. If you wrote speed, I'd take that. If you wrote velocity, I'd probably say technically speed, but I'd still give you the mark. Right? What's the equation of this graph? Well, every equation of a line looks like this. But I can do better than that. What's on my y-axis? May I? Yes?
Could you use meters as well, or does it just is it easier to use?
First of all, I don't like using that because that's going to confuse me with slope. And it's typically, we don't put the units in, we put the actual name of the variable in. You're right, yep. And you'll find out, because we picked a lot of this carefully, we try and avoid, where possible, using letters that also double as other stuff, just to avoid confusion. We're going to run out of letters because the English alphabet should have more than 26, but it is what it is. All good, Alex? You're not that important. M. Oh, M is the slope. What is the slope? 2. I'm not going to put an X. What would be a good letter to use for time? T. Plus. Okay. Bada bing, bada boom. Here's what I want you to realize. Here is our key idea. The slope of a displacement versus time graph is the velocity. Did I say key idea? Don't do that on your paper, but I'm kicking myself. I should have made this in huge, bold font. I should have put stars around here. I should have, done something like that. I'm not going to. I will next year when I retype this. But the key idea. But did I show you a clever way, Matt, that you could actually just figure it out from the graph? If you know, and I think all of you do, slope is what over what? Okay, everyone has that memorized? Did you say over divided by? Rise, the units on the y-axis, meters. Run, the units on the x-axis, seconds, meters per second. You know what? If you had a good physics teacher, he might have gone on a rant last lesson about it's worth memorizing what units go with which measurements. By physics 12, you'll find I can give you any graph that you've never seen before, and you'll almost always be able to figure out what the heck the slope means, because you'll just divide the units and, oh, I know what that is. So, now, what if it was a distance versus time graph? Speed. What if it's a position versus time graph? Probably technically velocity. I'm not going to be that fussy. What I do want you to realize is the slope of a distance or displacement or position time graph tells you how fast the object is moving. And maybe the direction, if the graph gives you some indication of direction, well, then it's a velocity. Is that okay? What can you say about the motion of this object here? Well, first of all, time is still increasing to the right. Oh, you know what? I should have been even more basic. What kind of a graph is this? Distance versus time. Okay. Time is still increasing, but what can you tell me about the distance in this graph? Ooh, good word. Constant. It's not getting bigger or smaller. The distance is staying the same. Maybe it's 5 meters. I don't know. So if you're always 5 meters away from where you started, and you're always 5 meters away from where you started, and you're always 5 meters away from where you started, what's your velocity? What's your speed? Yeah, what's the slope of this graph? No, as a number, what's the slope of this? 0. The slope of a distance versus time graph is the speed or the velocity. I said velocity in this question. Since you're not going anywhere anyhow, speed and velocity would be identical because there is no direction when you're at rest. Okay? Fancy phrase, we say this object is at rest. I mentioned last day when we're doing my DFIC approach, Megan, I said we look for numbers and for physics words. One physics word that you'll almost always ding, 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 if you see the word at rest, because that tells you something is 0, either an initial velocity or a final velocity. I'll have to read the question to figure out which one, but I'm telling you, something is 0. What can you say about the motion of this object? What kind of a graph is this? What versus what? Okay, so what does the slope of that line tell us? Ah! Nothing? Got Courtney. She's awake now. What does the slope of that line tell us? Velocity, you know what? Since there's a direction, we can even get a velocity out of here. You're right, you're right. Okay, so what direction is this object traveling? What if the line went that way? What direction would this object be traveling? South? Okay, lots of information in a picture. North. What does the line with a positive slope tell you on a D versus T graph? Well, it means forward or up or right. Or in this case, north. Or the graph would have to tell me. When in doubt, I usually just figure it's moving to the right because I imagine most of this is cars. To the right, I'll call positive. To the left, I'll be negative. So I have here sketched two different graphs of an object traveling to the backwards. You can cross out to the traveling backwards at a constant speed. I'll give you a hint. We'll start with that. How could I show traveling backwards at a constant speed? Well, another word for traveling backwards at a constant speed would be to say you have a negative speed. Yes? Where does speed show up on a distance versus time graph? I'll give you a hint. It's the key idea. So I'm going to ask you the same question with different words, but I'm telling you it's the same question. How could I draw a line with a constant slope showing that we were going backwards? You see Sheldon? He did a little Zorro. You know what? There. Is the slope changing? So I'm going to ask you the same question. I want the same answer. Is the speed changing? No. What's the word for a speed that's not changing? Begins with letter C. Okay. Constant. Is the slope positive or negative?
Negative.
What might negative suggest or connote as a direction? There you go. Oh, I said to draw two. Let's draw one that's going faster. What would that look like? Sure. In fact, if I did this, I would say, oh, right here, it came back to where it started from, but it kept going, and now it's receding off into the distance behind me. A lot of information, Alicia, in that little picture right there. Okay? So lines, the slope tells you the velocity or the speed, and we can make some kind of a direction, as long as it's the distance versus time graph, we can make some kind of a direction conclusion. Okay, you wait, Kev? Here's two objects, object A and object B. True or false? Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. True or false, object A traveled further than object B. So look at that graph. Object A traveled further than object B. You're going to vote, I'm positive, I'm pretty sure. I'm only voting because Mr. Dueck will make fun of me if I don't vote. He wants me to have an opinion. There's no risk here. So looking at that, object A traveled further than object B. Who says true? Ooh. Who says false? Convince me. Convince me. Where does how far appear on this graph? Yeah.
Distance.
More specific. On this graph.
On the left.
Looking for a word that begins with an H and rhymes with ite.
Height. It's the
Look, look,
height.
look, 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 look. That's how far they went, right there. Okay? That's where distance appears. So convince me. Oh, I can do better than that. I would probably just say, is that how far they went? Let's call that D. Is that their final spot? What would be a good letter to use for final? Oh, there you go. Convince me. C. There. Same, you know what? I could even say same final distance. There, that's 2 words and a little dotted line. That's worth 1,000 words. True or false? Object B had a head start on object A. Object B had a head start on object A. Who says, yeah, true, object B had a head start on object A? Who says false? Okay. What would a head start look like? Ah, if object B started like right there, it had a line like that. So there's a lot of information in this picture. Now, eventually, we're going to get tired of drawing these pictures. You have no idea how long it took me to find these on the internet and make some of the graphics myself. So eventually, we're going to do this all mathematically, but there's a lot of information there. They started same location, same time. They started at 0, 0. They both started at the starting line. Convince me. Both start at 0, 0. I could probably think of a shorter way to write that. Hey, which object was faster? A or B? And convince me. Prith.
A?
Convince me.
Because it covered more. Wait,
Okay, he just caught himself. He made a very common mistake. Because kids say, oh, A is a bigger line. Yes? Must be faster. Key idea. Where does speed appear on a distance versus time graph? Slopes. I'm going to ask you the same question. I'm going to phrase it differently. Which line is steeper?
B.
Which object is faster?
B.
Which line is steeper? B. Which object is fast? Right? Those are the key idea. When I say speed or faster or velocity, your brain can think steepness, slope. And if there's numbers, you can even do the rise over run. Steeper, slope. Okay. How could we draw an object that's speeding up? Is that an increasing speed? If you're speeding up? What did I say you could replace the word speed with on a distance versus time graph? The key idea. What's the key idea? Please, for the love of God, people, what's the key idea? No, what's the key idea on a distance versus time graph? What does speed or velocity show up as? So, I guess if I want to show an increasing speed, I want to show an increasing. Oh. You know what? Let's exaggerate it. Here. That thing's speeding up. Now here's the problem. That's a curve. How do you find the slope of a curve? This graph right here, this right here, is why Sir Isaac Newton invented the calculus. To find the slope of a curve. It's not rise over run, although it's a variation of rise over run, and I may tell you about it later if I have time. It was very, very clever. But for now, we can at least say, I know what it looks like. So, example 7. Describe the motion of this object. What's happening right here? What's happening right there? What's the slope right there if you zoom in? I would argue, I think, Courtney, the slope right there is, yes? So what's that mean? If the slope is 0. Key idea. What else is 0? If the slope is 0 on a distance versus time graph, what else is 0? Ah. At rest or stopped? So if they were speeding up and now they're stopped, can you tell me what must be happening in that section right there? I'm going to ask you this, slowing down, I'm going to ask you the same question. Look, what's happening to the steepness in that section? Isn't it decreasing, decreasing? What's happening to the speed? Same question. Isn't it decreasing, decreasing? So slowing down. Yes? Okay. How about here? Actually, let's make that a little higher. How about here? Could you give me a directional component right there? If you had to guess, would you say the car is traveling forwards or backwards, if this is a car? Okay, backwards. And is the line getting steeper or shallower? Steeper. So I'm going to ask you the same question. Is the car speeding up or slowing down? Steeper line, speeding up. What direction? This person, you know what? This person was driving forwards, hit the brakes, threw it into reverse, and now is flooring it and speeding up, speeding up, speeding up. So, speeding up backwards. Yes? Can you see the moment when they start to slow down going backwards? You see it? I think right around there, well, maybe even a little sooner. I think right around here is when the steepness starts getting shallower again. It could be a little higher. This is also one of the things Isaac Newton invented the calculus for. He wanted to know, this is called an inflection point. He wanted to know when exactly does that inflection point occur? When exactly have you gone from speeding up to slowing down? So it's very useful in physics. So I would say right there starts to slow down. Yeah. What about this section right here? What's the slope of that section right there? If I could draw properly, 0. What's the speed then? Fancy word for a speed of 0? At? Let's do that. We can get a whole story from that curve. And if you guys had calculus, Lydia, I could have actually given you numbers and you could have actually found the values of every one of those key points. If you're wondering, that'll be one of the first things they do in calculus in grade 12, the kids that are taking it. So what if we have a changing velocity? Now, this graph here is stupid, but it's all I can give you because you guys don't have calculus. I have to take something like this, which is a smooth curve, which is how things, John, move in real life. Trust me, I've been in a car. You don't zigzag back and forth. It's not like Tron or something like that, where things move like on a computer screen. Things are smooth and flowing and curved. I can't really give that to you. So here's my equivalent. Describe what's happening, it says, over each interval. In fact, let's answer the questions. A says, find the average speed over each interval. And I've noticed I forgot to put a point right, can you do me a favor? Right here in the bottom, I used A, B, C, D, E. Let's call that right there F. Oops. So over FA, over that interval, what's the average speed? Oh, where does speed appear on a distance versus time graph? It's the key idea. Oh, what's the slope? Slope is what over what? Okay. How high? 20, yes. By the way, I did this in a hurry by hand. It's the best I got. 20 minus how high? How high is point F? It's meant to be really obvious. 0. There's your rise. It's 20 take away 0. And Alicia, if you can do that in your head, great. I'm putting it in our notes just so we know what the heck we did. What's the run? 2.0. You know what? In your head, without a calculator, please, for the love of God, can you go 20 minus 0 divided by 2 minus 0? What is the slope? What is the average speed? 10 meters a second. What's the average speed of section AB? I don't think we need to do any calculations, do we? How fast are we traveling on AB? 0. Fancy word? At? Rest. Okay? Did I leave? Oh, good. I left room. BC. Okay. A lot of kids want to go, oh, isn't it 120 divided by 6? Well, how high is this? 120? How high is B? 20. So I think the rise is going to be 120 minus 20, 100, over. What's the run? Well, what's the x-coordinate of point C? 6. What's the x-coordinate of point D? 4. So I think the bottom part is going to be 6 take away 4. I think I can do that one in my head as well, but if you need a calculator, you can. But isn't it going to be 100 divided by 2? Which all of us hopefully know is. Well, is that line steeper than FA? Did I get a bigger velocity or speed? You know what? This answer looks good to me. I'm okay with it. If I had gotten a smaller answer, I'd think to myself, Haley, I think I made a calculator mistake or I counted wrong. Because I could have told you ahead of time, it's going to be bigger than 10. CD. Hey, are we traveling forwards or backwards? You know what? I'm going to put a negative just so I get it right away. What's the rise? This one we're going to try doing without writing anything. How high? How high? 60. What's the rise? 60. Technically negative 60. I already wrote the negative, so I'm just going to go, hey, the rise is 60 over. What's the run? 8 seconds. Drop down. I gave it to you, but you can also drop down. 6 seconds. What's the run? 2 seconds. In your head? In the homework, I didn't try and make them, or I stole a bunch of stuff from the internet. They won't all work out evenly. Sorry. But this one, I cooked the numbers again. D, E. Is this the last one? I think so. Forwards or backwards? Negative, you're saying? What's the rise? $20? What's the run? Also 2? Negative 10 meters per second. I freehanded this, which is terrible. If I had used software to make this, you would also probably, Sarah, have noticed that FA, positive 10, and DE, negative 10, had the same steepness. They were like mirror images of each other. It's not because I freehanded this and I suck. In case you were wondering. It's surprisingly hard, Courtney, to do these on a word processor. You'd be amazed how difficult it is. Oh. What do they want me to find here? Average velocity? Okay. Velocity, I'll put the vector sign. That's going to be displacement over time. It's going to be displacement over time. What's the displacement? Where did we start? 0. Where did we end? 40. What's our displacement? 40. How much time? Oh, I can do that in my head too. Alex, in your head, 40 over 10? 4 meters per second. What's the average speed? Well, average speed, which is VAV without the vector sign, it's going to be distance over time. It's going to be over 10. I got that. I'm going to break the distance up, Cohen, into traveling forwards and then traveling backwards. It seems to me traveling forwards, I got that far. How far did I travel forwards? 120? Plus. And then I started traveling backwards. And traveling backwards, I went that far. Yeah? How far is that? Don't tell me negative because distance is a scalar. But how far was that? Starting at 120, we ended at 40. How much further did we go? 80. That's what you said. Yeah, nobody heard you say it wrong. 80, yes? So it's, I could do that in my head too. It's 120 plus 80 is a lovely 200 divided by 10. My average speed was 20 meters per second. Okay. Here's our summary. A distance time or displacement or position, those are all kind of, they're not exactly the same thing, but I will this year tend to use them interchangeably. You guys have the summary on your page, yeah? Okay. Tells us how far an object has moved in time. Steeper the graph, the faster the motion. Key idea, slope is velocity or speed on a distance or position versus time graph. Horizontal line means an object is not changing. Here it says, I loved this graphic, I stole this from the internet, but above the word stationary, if you want to write the phrase in brackets at rest, that's the one that I'll use almost all the time. A downward sloping line means the object is returning to the start. If we threw it in the air, it's coming back down. If we were driving, it's now going backwards. If we started out going north, downwards would mean going south. We need more context, but those are going to be our general ones. A curve means your speed is increasing. You have room there, yeah? What would a decreasing speed look like? What's another synonym on a graph for speed? Also begins with letter S. Slope. What would a decrease? Oh, I think I just answered it, Jessica. A decreasing slope. There. That's slowing down. That's slowing down. If you really wanted, don't write this down, Alicia, if you really wanted to get technical, what would slowing down while going backwards look like? It would be a decreasing negative slope. I'm not going to worry about that, but we can take this to the umpteenth level. I stole a bunch of stuff from online, and at the very end, you'll see an answer key that I whipped up on Saturday here in 10 minutes. Was Saturday a nice sunny day? I think it was, but I didn't see any of it. I was stuck here. So the answer key was, it was about 4 p.m. in the afternoon by the time I was working on it, and I was getting a little squirrely. Candy for any mistakes that you find. I was doing it in a hurry. And these are kind of copies of copies, but I think they're all legible. I shrunk them down, but I think you can read everything. So look at the pictures, look at the graphs, and I think you'll be able to figure out kind of what we're getting at. I've covered about 80% of what you're going to see in the homework, and about 20% I'm going to say, hey, see if you can be clever. What's our key idea? Speed and slope on a position or distance versus time graph are synonyms. See if you can figure it out.